I'll do what I don't expect to be more than 10 or 15-minute refresher about the work that's been going on here, but certainly feel free to interrupt there, and then we can talk about whatever directions we want. Um, a little bit of introduction to myself. I've done some diversity of stuff in our field. I started as a embedded system designer, making kind of system level hardware and firmware. I've spent the bulk of my career as an analog and mixed signal IC designer, most of the time at Apple, and really became like a pretty frustrated one with the sort of act of uh, doing that job, right? The act of designing in our field, and was away from it for a bit, and the last 3 or so years, I've been at UC Berkeley as a PhD candidate. During that time, I also worked at Blue Cheetah, which, given the group here's interest and overlap with BAG, I'm sure you're familiar with as kind of the BAG company, and on some other um, kind of novel EDA stuff at Google X last year. The pile of software talk about today includes a few things for analog design and starts with the sort of premise that I think we have a lot of difficulty just in making use of underlying layers to make bigger, better stuff. And a lot of that comes in several angles. One is how good is the output in terms of circuits. Two is how good is the software and how approachable is it for people to use. And three, perhaps the most painful one, is just how well can we actually share it amongst each other and amongst institutions. So some of the fairly low level to a designer, things that your typical designer doesn't look at all, is like the format of the design database. And so the first sort of sub-project of the suite I'll show you is called VSIR, which is a design database made and written with the Google Protocol Buffers project. That and a few kind of daughter cousins are essentially originally designed as data interchange schema generators for cloud scale interaction between services. The general gist is you write a program, you write a quote unquote program, you write a schema, so a set of data structures in this schema description language, and then a compiler walks over it and produces sort of interface code for pretty much every programming language you would want. So the utility of this to us, well, first and foremost, this is open source, everyone's free to use it. Second, we do have, I think, a fair diversity of sort of applications as far as the kind of software that's going to want to touch this content from, with a pretty good diversity of performance versus sort of usability demands. So this serves as kind of the central interchange for everything in this VLSIR project or VLSIR family. The data schema sits
See,
in the middle, please.
quick question. So you can you go back one slide? So like, right, a lot of the commercial tools, let's say Cadence, right? We'd kind of want some sort of interface there, especially if you have to work with, existing work, right? Um, so do you see like having some sort of skill version of this uh, to interface with the schema?
Some sort of skill version of this to interface with the schema.
like
Um,
uh like an API, skill API that could use this schema and like you're saying
You can add
interchange between those
you can
languages.
you can add a protobuf backend, so to say,
there are a
for
couple of
generate code for.
routes.
Mhm.
There's a couple of routes to interaction with the cadence formats. The one that, in all honesty, was a lot of the motivation for this that BAG once upon a time made a very fateful decision to pursue is to use the open access API sort of directly. So cut out Virtuoso, cut out the skill interpreter. This is largely a performance consideration, but if you're a member of SI2, Silicon Integration Initiative, you can get the sort of raw the C++ API to the underlying data. Um, Sadly, our institution then lost membership, whether it was through a change of terms or just a change of our opinion about the terms. We are no longer able to be members of SI2. And so we've been without that for at least the 3 years that I've been here, and I think more now. That is also, in addition to some other factors, one of the material factors why there's really not bag development here. I will say there has been an effort to sort of revitalize, kind of a small scale effort to like revitalize bag as like a skill based, or at least skill and virtuoso in the loop thing. Personally, when I say things like sharing this stuff is one of the real pains, and getting people to be able to approach it is another one of the real pains. Things like having a skill interpreter and what is that in the system are exactly things that I kind of point to as problems. Um, so that's very certainly a possible thing to do for someone who knows skill well enough to like either write a protobuf compiler to it or just write the code to interface with this schema in particular. It's certainly not something that I anticipate doing.
Okay.
And the other very important virtue of this is that all this work is open source, all of it is permissively licensed. So everyone else who likes any given chunk of it is free to uh, change any other fraction thereof. It's a good question. The picking up the sort of data schema serves as that sort of central interchange for a bunch of software, largely inspired by another project, LLVM, in which there's this central interchange separating sort of front end and back end components of the pieces of software that touch it. In VLSIR and kind of our lands, we'll look at a few of these, but generically labeling as fancy front ends to produce this VLSIR schema using the bindings to a couple of languages in particular, but this will look at the sort of fancy front ends for circuits and schematics, and I suspect we'll talk about layout. And on the back ends, the sort of back ends are essentially all of the industry standards. So to your question, if you imagined an open access or virtuoso such interface, it would live on this layer as well. As is, the things that do are things and formats and concepts like those in GDS and LEF, popular circuit netlist formats, popular SPICE simulators, input and output, for sake of kind of in-loop simulation running and reacting. So a sort of general gist of the kind of stuff that is in this VLSIR schema, not in syntax, but in concepts. There are three major headings of design content really pretty comprehensively covered. They're circuits in sort of module form, they are layout, and SPICE input and output. So those three things exist in that protobuf lands. I should note that protobuf being an efficient binary format is an important trait for the layout in particular. But this is, the stuff down to bottom, right? There's no underlying external thing where the real core intellectual content of these designs live. It's in this VLSIR format. The primary sort of what I labeled fancy front end for circuit design is called HDL21. It is, as named, an HDL, hardware description library. It's embedded in Python. The real goal and intent here, the real realization is many of the folks who have the skills to make these circuits, those skills are hard won, right? That is difficult knowledge to come by. And in many, I would say most cases, a bunch of programming expertise doesn't come along with it. And so the sort of central question and goal is, can we sort of expose what I think is a more, and we think is a more powerful means of producing and describing these circuits, which is in code, to the people who are, like, in some sense, novice programmers, pro circuit designers, right? So not going to be the most amenable to it. So the most meeting them where they are possible. And there are a couple of tactics, a couple of kind of patterns that are the sort of tenets of that approach. Really, the two that I'll feature here are, there are two very central concepts. One is HTL21's module, which is a data structure. I mean, think of this as, this is the struct of this hardware language. The usual means of defining them is to define a Python class and declare attributes much like you would in a popular dedicated HTL like VHDL or Verilog. The things that designers are used to, the concepts that they already register, like signals and inputs and outputs and instances of other modules and connections there between, are the central currency here as well. They're the kinds of things that get instantiated in these HTL21 modules. And really the thing behind the scenes that makes it a module is having defined this class, stick this little decorator widget on it. And that's sort of how and where the library applies its magic. The second sort of paired such idea, and really the one that unlocks, another level of capability, is HTL21's generators. We have really stretched that term generator quite thin here at Berkeley. Not sure what most folks think it means. I am confident that it means different things to many different audiences. Here it's a proper noun, and it specifically means it's a Python function that returns one of those modules. So parameters come in, construct the module by any means you like, defining a class, doing so procedurally, add subsystems depending on the parameters. Just, you think of this as sort of Python level version of Verilog generate with a focus on analog circuits. The focus being on analog stuff. HTL21 also includes kind of all the stuff that every analog designer uses day in and day out, and only they really care about and love. Things like the generic primitives, something like generic versions of all of the primitive elements in SPICE, like transistors, passives, bipolars, diodes, specific technology versions thereof. So PDKs in the system are Python packages that you import the same as any other. Mapping there between. Very crucially, SPICE simulation. So another sort of decorator on class full of stuff is the usual mechanism for constructing sort of the input to SPICE, and then firing off simulations, getting the output parsed back to sort of react to in a, whether it's for reporting on results or for further optimizing some circuit. So this is kind of all the stuff that the usual practitioners know they need. There's also stuff that they honestly do and use all the time and will swear up and down they don't need. A prominent such example are like what I call the structured connection types. So in another popular project here, Berkeley Chisel, we call these bundles. In System Verilog, they call them interfaces. Basically structures of connections. So if you imagine there are 10 signals that always travel together, I don't know, maybe in an HDMI cable or in a SPI bus, or in some control interface to a particular IC subsystem. Having those as a concrete thing that is instantiable and just travels together in HDL code does help a lot. And analog circuits will claim to not have these, but actually have them all over the place. And the most prominent one is just a differential pair, right? This one is so prominent, in fact, that it's built into the library. It's two signals, P and N. And it's, in fact, so prominent that there's some more infrastructure built in each node around them, particularly what commonly do with differential signals is hook them up to differential hardware. So there's a paired utility called pair, which in this case which means two identical instances of anything you like. In this case, there are two of these pairs instantiated. One is something called ninp, so some NMOS type that came in from off screen, and a pair of something called RL, which is some resistor type that came in from off screen. The general premise here, the general goal of HDL21 in a sense is replacing schematics. That said, I've done this for most of my career, and I still do find, and I think most graphical schematics out in the world would be better as code. There still is a subset that I just think this picture imbues a lot of value. One example on screen, right? And this really became clear while trying to teach our first-year students. We're trying to help them prepare for one of their big exams. Just how much more difficult it is to both conceptualize and especially convey what something like this is doing in code versus in this picture. So there is a paired schematic system with HDL21. The central sort of theory and realization is schematics, two things at bottom. It's a circuit and it's also a picture. And every system I can name sort of prioritizes those things in that order. And there's a lot of value in making it a picture first. Notably, you can view it wherever you want. You don't need a fancy server with, an IT department and weeks worth of setup and stuff to be able to open such a thing as a picture. The sort of paired, I think, counterintuitive, I would say, fact is schematics are read mostly. Even when designing them yourself, much of what you do is just look at them. So that's a central goal, is don't require all the specialty software to read, but then perhaps even more importantly, be able to make nice, good pictures like this without the very ugly ones that we know accompany them. And I think the very simple reason the very ugly ones accompany them is they're just entombed in this kind of system together, in this, whether it's Virtuoso or some other environment that sort of just makes it much easier to continue making schematics than to branch out into code land. So the way HDL21 schematics work is they are natively, directly importable and runnable sort of graphical Python modules. So the amount of infrastructure needed to get them into code land is quite literally just the language's import keyword. On the reading front, one very helpful fact about being able to read them natively without like a connected database and a bunch of setup is platforms like GitHub and GitLab can render them natively. In fact, here are examples of GitHub and GitLab rendering each the same schematic. Editing, there are a couple of mechanisms for doing so. The one that I think is the most compelling and sort of intend as the primary mode is this is an IDE plugin. So you have a pile of HDL files, and you also just intermixed amongst it have files of format .sch, .svg. All the schematics are SVG images. Which there's a pile of Python code that knows how to import and run as HDL21 generators. So in this example from the most popular IDE, VS Code, the ring oscillator Python module is a file in the file browser at left. The inverter schematic SVG image is opened in the tab at right. There is a custom editor for these. So in fact, the sort of picture being shown here is sort of rendered by the custom editor, as are things like the code prelude that we'll look at editor and the means of dragging and clicking around and drawing wires and such. And the interface between these really is just from the first inverter here refers to that file name, and the second refers to kind of the function defined within it by the picture, and start instantiating them. So the important goal there is, again, this get out of, I think the schematics are valuable. These schematics that are valuable are the ones where people can generally agree on what the elements in them mean. So enable those and then get into code land as fast as one can. One other very helpful fact about having this code interaction is you can do things in these schematics that you can't in any other system I'm aware of, which is they each have a little code section. We call it the code prelude because it kind of runs before the pictorial defined section, where the generally do about three kind of categories of things. The one that has to happen is sort of import and define whatever is going to be instantiated. But the other very helpful fact is you can define variables of arbitrary complexity, right? So in this example, p bias is a thing, is sort of a parameterized version of a thing called PMOS, where width and length have been applied to it, and then each of the instances affixed with that variable are of that shape and size. The cascodes are a smaller, different size, very common tactic, and there's also many of them that you'd like to keep as the same set of parameters. And a similar thing for this bias resistor down here. So I'm going to pause there. That was a little longer than I intended, but kind of a refresher on this stuff, and open it up for. I apologize. I'm not terribly familiar with the group or audience, so if you guys want to lead the way on what you want to talk about, I'm happy to.
So can you edit that schematic right in VS Code there?
Yes, there's yeah, that's the intent, and perhaps I didn't say that explicitly. That I think there are two people come to hear the statement like there is a schematic system from kind of two perspectives. Let's call it analog perspective is there's a schematic that I draw. All right, so I decide where to place all the elements. I decide how the wires are going to look, and that is this system. Perspective two, the sort of visualization slash debug slash kind of more digital one is like there's going to be some code, there's going to be something else, and something is going to infer a picture to help me envision what's in it. And that's not what's happening here, right? So my perspective, and this is paired with those very nice sort of very niche analog circuits, is these pictures are as good as the effort put into drawing them, right? So the fact that there is a good way to convey this information visually really means, or really I should say, the point of having them is that someone is conveying information visually, right? So the editor there's one piece of sort of TypeScript and web stack code that runs in a few different contexts. One is a dedicated desktop application, which is to date gotten the most use in large part because it's sort of the easiest to develop against and debug. The second platform is that VS Code extension, which does exactly the same editing functions. And the third is just on the web, right? So we haven't stood up and exposed a public web server using this, but it is certainly something you can do and run locally, and is of all of the type of software that will run in your browser if pointed to some server side set of schematics.
Okay, cool. And then I guess could you talk about process setup? Like what do you need to prepare to be able to use this for a given process, right?
Yeah. So that differs a little bit between the HDL and the schematic system. And did you have one in mind by this when you in your and that pronoun this.
Um,
So
I suppose starting with just using HDL21 to, yeah, just to create, let's say we have existing schematics. Like I know in your other presentation, you had a schematic with just two boxes, right? So how would I start replacing that with some HDL21 code? I guess so like the bare minimum to get that running. And then I guess how would you then have also replaced some of our other schematics with or what would we have to put into place to, use the schematic feature too?
yeah, so the perhaps counterintuitive fact about this is to start replacing schematics, you need to import or do nothing, you just draw them. And that is very tightly paired with the fact that the schematics are in a general purpose image format, which, GitHub can render. If I email you one of them, you'll be able to see it as an image, probably even inside the body of the email, but certainly on any computer that you've bought in the last 15 years as a file. The important fact about that is there's no linking of like a database or a technology file or anything before the fact, right? So that is part and parcel of how platforms like GitHub can show them as photos, as images. So the where that happens in contrast is in that execution stage, right? When they're pulled in and run as the HDL21 generators, each of the schematic elements, perhaps the last slide I showed is the best for this. Each of these schematic elements has a kind of two specifiers. One is one you're used to, it's the instance name. And their other field, this thing labeled pbias and pcast here, is what we call the of field. And in the picture, in the SVG image, that's quite literally just a string. There's no link to anything. There's no sort of semantic content to it. It's really the program importing and running these behind the scenes that imbues it with that is going to be from this particular technology, or it's going to be from some library. Really, what this picture of a PMOS brings to the schematic is two things. One is what it looks like in the picture, right? So like this triangle and this circle and the visual information. And two is the port list. It brings the fact that this is a thing with the port names DG, S, and B. And the program and the combination of the program behind the scenes and this of string sort of map into any given technology or thing that has those four ports to turn it into kind of a circuit or module or netlist. On the other side of that equation, on the kind of in the HDL, as I mentioned, the PDKs are Python packages. So taking the open source Skywater PDK as a prominent example because it's open source shareable, this is a PyPy package that you can pip install right now. And what it and each of its sort of brethren primarily include are two things. One is a set of modules. They're more specifically what we call external modules, which are sort of black boxes of port list and parameter list with no implementation. And two is a sort of compiler, which is really a sort of mapping method to take HDL21's generic primitives and turn them into the technology specific ones. So in this example, we create an inverter with the PFET and NFET from that Skywater tech, from particularly the modules sub namespace. Making the same thing with the primitives has some benefits, particularly they are generic, they're process independent. And then, so creating those with these things from HDL21 primitives and MOS and PMOS, we instantiate things by those names with fields like the threshold voltage. And then each of the PDK packages has a method called compile, which semantics are take any generics and compile them into our technology. Right? So these two slides produce the same circuit at the end. One is also amenable to being compiled into any other technology you have at hand. The standing up of the technologies is also not one other helpful fact about that is standing up technologies is not especially complicated, especially as compared to what you might be used to, particularly for a lot of these libraries that attempt to genericize custom layout, where really standing up the technology is like a whole project unto itself. These are more like 100 or hundreds of lines of Python code, really only maybe a dozen or so of which are like really central to the intellectual content of what it takes to map primitive devices.
Um, Now that you mentioned layout, I saw there is some layout 21 with this polygon based and I think Lego, also Tetris based helpers. But yeah, so what we saw until now was more dealing with schematic and web spice and so on.
Sure.
On this side, I would be interested in this layout side, so to say, as we are at SAL, we've been working with Back2 as a layout generator. Yeah, it would be interesting how layout 21. And also, if there are some examples online, I didn't see any example code using layer 21 yet. Yeah, okay.
Yeah, which is, in all honesty, a longer story. And as it really is kind of a pile of, it is a set of different approaches built in. Maybe that reminds me of, is our whole audience kind of in the bag milieu, the Infineon slash groups who have used bag?
So if your question is whether we know back too and have some experience, yes, I think, and we know also the let's say the various disadvantages there and so on. So at least we see that it's definitely not the optimum. If this is your question.
Yeah. So why don't we talk about layout? We
But maybe, I mean, Martin, maybe if I can step in a little bit and ask first one thing to Dan before we change to
Sure.
layout, because also the schematic part, one question comes into my mind. So then you worked for quite many years in a big company or in big companies, and I mean, you don't need to convince me personally that this move to more programmatic approach, also connectivity wise and so on, would be a great one. But how do you think can we convince the bigger community out there that currently is working in Virtuoso and say, yeah, this is always the case. I had to draw a schematic and so on. How can we gradually convince those guys to move more and more into this more programmatic, Pythonic, maybe mixed environment where some blocks you still describe by an SVG schematic or whatever? Do you have some personal feeling how we could succeed there to convince those guys gradually? And because we cannot introduce in a big company, you cannot introduce such a thing like a big bang and say, now for a few projects, we change completely to that environment. Because then many people will come along and say, yeah, but you're going to integrate this IP block, this analog IP block into my big top level. And there I'm working with with Cadence Innovus, and I want you to provide a Virtuoso XL database. And these are the nasty constraints from the top.
I think there's a simultaneous pro and con at the center of that answer, which is, each of these places has their own sort of bespoke, what they'll call flow and culture around how they use all of this pile of software. I can certainly say for the places I've worked, the uses of Virtuoso is more baked into the culture than just the fact that the designers are used to it. Although the fact that the designers are used to it really drives all of the sort of behind the scenes use cases thereof. I think that the short answer is like the biggest, most successful, highest functioning companies are going to be the last to ditch whatever's working, right? Like the places where I get a lot of interest are from startups and for people who are more on their own, right? Especially if you don't already have this infrastructure of standing up the technologies and even paying for the license, honestly. Then stuff that's in this, everything down to the design database is open source becomes a much, much more valuable proposition.
Mm-hmm.
And the other important thing, I think the example you cited of, I need to get stuff into Innovis is we also do have industry standard formats that suffice for that, right? So you can get like GDS and LEF and net lists that perform that function. Now, I do generally agree with it that like if the goal is totally replace entrenched industry, it will and should seem daunting. I think I think of everyone as kind of on a spectrum of amenability to how I would prefer for this to work, which is this kind of more software centric mode. And there's a lot of practitioners. There might be a high correlation with being of, let's say, higher age. There's just no chance, right? It's the way they're used to doing it until the end of their career. And there's every point in between, right? There's somebody who's like looking around online, itching for something like this, and there's somebody who you couldn't pay them. They literally would, hand in their resignation today if they like had to even entertain it. And this is why this kind of spectrum is why I say the important thing is meeting these people where they are, which is expose the concepts they know, expose them in the sort of simplest software terms that you can. If there are simpler ones, then this is as good as I can dream up in that respect. But it does start with this caveat of those meet people where they are, given we want to make this kind of a more of a software or design process, right? So there obviously are approaches that are even closer to where they are. If they're using all Virtuoso, it's like use mostly Virtuoso or some Virtuoso. And in all honesty, like one of the things I've been sort of pitching here quite some time is, you guys want to continue to develop BAG, why don't you make a version of BAG where like HDL21 replaces the schematics? Like you have a Python library, it does all this layout stuff, and then you have this you have one of two really horrendous interfaces to kind of the front end circuit content, right? One is this OA thing that we can't even develop or use anymore, which forces you to draw a schematic and then also write a program that just breaks it and makes it look awful. Option two is do that, but do it through the Skill Virtuoso interpreter, where you do the same thing but about 1,000 times slower, and it makes the whole process take minutes instead of seconds for even the simplest circuits. And that hasn't, at least amongst the pretty small remaining community that cares about BAG, that hasn't got a lot of traction, in large part. I don't honestly know like why, but I do think that the Virtuoso schematic just has like a real grip on a lot of people, including some that otherwise in like other aspects are sort of quite amenable to doing this stuff a bit differently. So yeah, that's a lot, and that's like perhaps that's like a counterintuitive case I just cited, but I just think the big picture answer is uh, there is this sort of spectrum of amenability to this stuff, and you can't go after like the least amenable people first.
Yeah, thanks for
I
your
think,
sharing your
So,
thoughts. Yeah.
I
so
think I think you have a third option. Did
What were
you?
the first two?
The first two is the first two that you mentioned, but the third one you didn't mention. So I'm trying to think about it. Did you hear about what we call OA script
I'm sorry, what are the first two options that I mentioned?
in layout, in going using Virtuoso skill or doing your own layout, but nobody is really using for coding? I don't agree with you. I think you have a value in what you are doing. And I think if you created a converter from BAG to OA script, it's a Python based version of open access. I think you can bring lots of value.
So that falls into the category of needing the open access API, which we
But
do
you
not
don't,
in
you
Connect
don't
yet. Do not
integrate,
have in Connect yet.
yeah, you don't integrate it into your generator, but you can do a converter from your generator to open access. Yeah, to OA script.
Yeah, so one I'll sort of frame that. So there is a thing called OA script. It is a very light wrapper into scripting languages over that OA C++ API.
Yes.
In all of my prior commentary about that, again, it's perfectly possible to like the sort of conceptual core content of everything I'm showing you here has a pretty literal analog in OA, and someone who cares to convert to OA certainly can. That is an approach that in all of my prior commentary, falls into the use the OA API bucket.
Mhm. Because in general today companies would like to do scripting because they want to build our own libraries even for small devices, not for big circuits. And in case of migration and so on, you just grab the devices or the generators from this library and then use it directly. This is what people like to do today in design companies, so even big ones. So it's a one-step process, and then they have everything set for future uses. So if you provide a link to industrial approaches also, it might be interesting also.
But it's not a, let's say, a contradiction, because I think Dan also showed that one part of his idea is that you have this front end with this mixture of schematic SVG plus really interesting Python classes and decorators. And then at the very end, you can then decide export that connectivity that you define there into a LEF, a DEF, whatever, or into open access in principle.
I speak on the about I like what you did on the first schematic. I speak particularly about the layout part.
So now, okay, maybe it's time to switch to the layout part now then.
well, could I ask one more question? So,
Okay.
I mean, you talked about meeting people where they're at, right? So how, I guess, let's say we're in a, virtuoso centric design environment, right? How close or how much effort is it just to replace, start with one or two schematics out of that, right? Choose the the most important or the most advantageous schematics to convert over. Like, do we have enough integration between the two such that that would be easy, or would that be kind of hard to do?
Yeah, again, the amount of direct Virtuoso and Cadence integration is exactly zero. And the amount that I intend to make is zero. And I should say there are like these sort of backdoor combinations of piles of software. So, for example, BAG will turn your Virtuoso schematics into sort of a markup format, YAML-based markup format. It's actually very literally done to conserve Virtuoso licenses, and then you can sort of backdoor the content out of them that way. But the the meeting people where they are is on the conceptual level. It's not on the file formats and stuff, level. This is, again, like I said, the premise of if you wanted to say, I'm all in Virtuoso, what is like the minimal step I can take? That's not the approach or goal of the whole VSIR system. The approach and goal is the fact that you're sort of entombed in this problem is a big part of, in this Virtuoso land, is a big part of the problem. And particularly when it comes to things like being able to share this stuff with each other. So I don't, clearly there's a lot more emphasis amongst the group here on Virtuoso integration, and the short answer is it's not part of the story.
Yeah, makes sense. Thanks.
So I
So
think now you can.
I think layout is a longer, I don't know what the um, schedules here are. I will have to go shortly. I don't think that layout is an 8-minute topic.
Hmm. Can we do a
Sam,
follow-up perhaps
yes,
on
please.
layout?
Not possible.
So, what do you think are, I guess, the biggest need right now? Like, what do you, if you had help, where would you need it?
Uh, we've got a pretty diverse ecosystem, and there's a lot of opportunity for things to get better across the spectrum of what people find important. I mean, one very obvious case is, especially since this is kind of a product for circuit designers, is just make and publish more circuits, right? Like the that's usually the most valuable act for me in producing, what's important, what's useful. But everything from, the other good news is the sort of tracking of what works and doesn't and what's desirable. We do very actively use the GitHub issues as a publicly visible, statement of where things stand and where we wish they did. So, all the above, I think layout is like the most, I don't know, my short, like, kind of bit on layout is I think there have been very few successful models for producing IC layout, and I think all of the kind of recent research ones have really kind of failed to capture even a small fraction of the productivity of them. And so I think it does take a pretty healthy overhaul of how we're going about those. So that is like, that's tough to say, like, okay, chime in for some small fraction of someone's time to this kind of like constant, this big picture stuff. But on everything I've shown, like there's sort of everything from reasonable size down to like very incremental things to get better, to get more like the sort of vision of how you'd like it all around, right? Like if there is a lot of interest in OA and one of the, member institutions has access, that's like a great, that's a great thing to have. It's my sort of message about it is that I don't anticipate doing it, but I certainly think it is a very valuable piece of software to exist.
But I think for the remaining minutes, we should maybe do some, let's say, appointment for a follow-up. And I'm also interested, I think, then are you going to share the URL of your presentation that you on Google Docs that you showed today, or is this?
Yeah, I can show you slides. That's fine.
Yeah, but I mean, also browsing through that one and maybe making up your mind. If I mean, next month I have a little bit more time, and not this month, not this week anymore.
Why don't we circle back on that? I don't have